Welcome to this eLearn security video lesson on working with Autopsy. In this video, we will introduce various features of the Autopsy toolkit, which is very useful when investigating digital crimes. Autopsy is one of the best tools because it's an open source toolkit and, when compared to other tools like EnCase and FTK, it really does a good job. Let's go ahead and open Autopsy. In this video, we will use Autopsy to analyze a forensic image of a digital crime. During the video, I will also go through most of the features available in Autopsy, so you can use the toolkit later to solve labs and help you in your work to solve digital crimes. When we start the tool, we get this welcome message, which gives us the option to create a new case, open a recent case, or open an existing case. Let's select Create New Case so that we can see all the steps from the beginning. Here, we see the New Case Information window, and it's prompting us to create a case name. As mentioned in the slides, we must give every case a name as it allows us to differentiate between cases. For this particular case, let's name it Case 01. Next, we see the base directory, which allows us to select where we'd like to store the case. Let's click the Browse button, and for this case, let's select this PC. Then, the D drive, and then create a directory here, which we'll call Case Analysis. Now, let's click the Next button. Here we need to enter a case number. Since this is the first case, let's type in 01. The next entry field is Examiner, and here we can enter our name as the examiner who will be examining this case. I'll enter my name here and then click the Finish button. Autopsy is now creating a database that will contain all of the results, and the analysis will be stored here. The speed of this process depends on the speed of your computer, as well as the size of the forensic image being analyzed. Here we have a couple of options that we can select. The first option is Disk Image or VM file, and this is the one that we will be going through, meaning we'll be selecting a forensic image as our case. Next is Local Disk. If we have a local disk that we wanted to do live analysis on, we could select this option. The third option is Logical Files, and would use this option if we have several logical files that we wanted to analyze. And the last option is Unallocated Space Image File. If we collected unallocated space from a suspect system, Autopsy has a feature that will allow us to load and analyze it. Let's go ahead and proceed with the disk image or VM file selection and click the Next button. Here we need to select and browse for the image file we're going to use, which is Case 01. Next, we can select the time zone of where the image was acquired. If you don't know the time zone, it's best to select GMT 0. Here we have GMT plus 0. Let's go ahead and click the Next button. Here we have a new window with several different features that we can select from that will be applied during the analysis stage. Autopsy will use these selections to apply the appropriate plugins to perform the selected task. Let's go ahead and explore these features. The first option here is Recent Activity, which says the selected module has no per-run settings, meaning we don't need any settings to run it. This option will extract recent user activity, such as web browsing, recently used documents, and installed programs, and then analyze them. Let's look at the next option. Let's say that we found a file on another system, and we want to check out some hash files on our system. Then we can select this module. Let's click the Global Settings button, and then the New Database button to create a hash database. Let's name it Test, and set the type to Known. The database path must be entered, so let's store it here and then click the OK button. Here we can add hashes to the database, and then index this database to be checked. While Autopsy is analyzing the forensic image, it will check every file's hash value to see if it matches the hash values in our databases. Let me provide an example. With the acquired hash value, we want to search for it on the suspect forensic images. What we will do is create a database, add the hash value to the database, and make sure that Autopsy indexes them. Then we can run Autopsy using these hash lookup values. This will check the forensic image for any file that has this hash value. If a value was found, that means that this file is a match and is the same as the malware that we found on some of the other systems. We won't be doing this right now, we'll do it later, but I wanted to show you how. Let's also leave this unchecked so that Autopsy won't run this module. If you have another file type that Autopsy hasn't already identified, and you want Autopsy to identify it, then you can add a custom MIME type to represent that. Here is Embedded File Extractor. This feature will extract embedded files like doc, docx, ppt, pptx, and xls, to name a few. EXIF parser will extract metadata from JPEG files like geographic tags from photos. The next option allows us to search for keywords in the forensic image. For example, we may be investigating a crime and have generated a list of words to search for and can add them here. Here, we can select various search options like IP addresses, phone numbers, and email addresses. This box is checked, as is URLs, so they will be extracted. If you suspect that this image has credit card numbers, you can select this option. If we go to email addresses and then select the Global Settings button, we can add information here as well as update various settings. Like here, we can even select different languages that we could be using. Autopsy can identify several different languages other than English, so if you're investigating in another language, don't worry. Let's now select URLs and click the Global Settings button. This is where we can add URLs. Looking at the next module option, we see Email Parser, which will parse inboxes and PST and OST files, which are used by Outlook. Next is Extension Mismatch Detector. This checks for the file magic number or header, and then it checks its signatures to see if they match or not. For example, the header is saying that this is a portable executable file, but the extension says it's a TXT file. We have an extension mismatch. This is what Extension Mismatch Detector will do. The E01 verifier can be used to validate the integrity of E01 images. We will not be using an E01 in this video, so we will not select this option. Next up is Interesting Files Identifier. Here we can add rules to find interesting files. PhotoRec Carver. Here we can see that PhotoRec is embedded into Autopsy, so we can run Photo Recover to carve files from the unallocated space that is found in this image. Correlation Engine saves properties to the central repository for later correlation. Virtual Machine Extractor extracts virtual machine files and adds it to a case as data sources. For example, if we know that the suspect is using a virtual machine, then we can select this option to extract the virtual machine from the forensic image. Finally, we have the Android Analyzer module, which extracts Android system and third-party application data. So, we can even analyze Android stuff using Autopsy. We will not be using all of these modules and will stick to the ones that are already selected. Let's go ahead and click the Next button. Now, Autopsy will start the analysis. So, let's click the Finish button. Here we can see that Autopsy is analyzing the system, the forensic image. If we turn our attention to the left side of the window, we can see the data sources and that we have one case, which is an image type. Here we can see the size in bytes, and that the sector size is 512 bytes. We also see the time zone we have selected, and here we see the device ID, which is the volume series number of this image. If we expand data sources, we can dig deeper. We now see the type of volumes. The first volume we see is for the unallocated space. Next is an NTFS volume. And this volume here is also an NTFS volume. The last volume is also another unallocated space. As you may recall, this volume is the system volume used by Windows. This volume here is also system volume that's used by Windows. If we drill down into this volume, we can browse through the files where we can see file names and timestamps. We have the modified time, changed time, access time, and created time. We also have the size and flags of the directory, which tells us if it's allocated or unallocated. We have a lot of useful data here, and we only browse the directories. Let's go to Views and expand file types. Here we can see that they are categorized. Within By Extension, it's categorized by images, videos, audio, and archives. Let's select Videos. To the right, we get a list of all the videos that have been found on this forensic image, regardless of their path. In the Location column, we can see where they are found. Now, let's expand Documents. Here we can see that it's categorized based on document type, making it very easy for us to analyze documents or find certain files on a system, like PDFs. Or we can look for executable files, which are also categorized. There's even a categorized by MIME type, but since we didn't run this module, we don't have anything in here. Next, let's expand deleted files. Here we can see deleted files. We can easily tell that a file is deleted by the icon, which is a white piece of paper with a red X mark. So if we click All, there are 4,103 deleted files. If we select a file, the details for this selection will appear in the window below. Within Views, we also have the option to see the views based on file size. We can search for files with sizes between 50 to 200 megabytes, 200 megabytes to 1 gigabyte, and even files over 1 gigabyte in size. This particular file, the pagefile.sys, is more than 1 gigabyte. If we scroll to the right, we can see its exact size. If we scroll down, under Results, we see Extracted Contents. The first option will show us devices attached to the system, like USBs, devices, tablets. Next is XF metadata. If we select an image, we can view the image and can see the details of its results, as well as the extracted metadata, like flags and creation times. We can see information on strings that have been embedded into this file. We can even find the hex representation. Now let's explore installed programs. This allows us to find what type of files or applications were installed on the system. Here we can see that Adobe Flash Player 11 ActiveX, along with its version, was installed on the system. Beneath this, we can see that CCleaner version 4.04 was also installed. The next selection, under Extracted Content, is Operation System Information. This lets us know that we are dealing with Windows 7 Professional Service Pack 1. Looking in the window below, we see several pieces of information like installation location, product ID, and owner. Next, we have Operating System User Account, which shows us the users found on the system. We can see the username. Here we see a username called Suspect. It's called Suspect for a reason, as this is a testing image that we are using to record this video. Actually, I'm using David Cohen's forensic image for this video. Here we have Recent Documents, which shows the recently accessed documents. Next up is bookmarks. Here we see a list of bookmarks that are found in the forensic image. And web cookies can be found here. Lastly, here we can find web history and user activity in this tab. Autopsy is a great tool. It provides so much information. If we look at the bottom right, we can see that Autopsy hasn't even finished. It has only finished around 7% of the analysis. I have one more thing to show you, and then the video will be paused so the process has time to finish. We'll resume it once the analysis is complete. Let's go to Users and expand Suspects so I can show you this final feature before we pause the video. Let's say we want to add a tag to one of these so that we can come back to it later with just a click. Plus, doing this will be helpful, especially if we want to add this to a report later. To demonstrate this, let's select Pictures as there are files here. Now, let's right-click, select Tag File, and then Tag and Comment. In the comment field, let's type in Pictures and then click the OK button. Now, let's scroll down to Tags. Expand Bookmarks and click on File Tags. Here we can see a tag for pictures. Let's select and right-click it. Then choose View File and Directory, which will take us directly to its location. This is very useful when you're analyzing a disk and you suspect something interesting and want to add it, so it can be extracted later or added to a report. If we right-click this tag, we have an option to extract the file. If the tag is no longer needed or nothing of use was found, we can simply delete the tag. The video will be paused now and will continue once the analysis is complete. Autopsy has finished analyzing the forensic image. To give you an idea of how long the analysis took, let's click on the Ingest Messages icon at the top left. Here, we can see when the investigation started and ended. So, it took about 3 hours to analyze this disk, but, as mentioned earlier, it depends on your computer specs and case size. If we have a big disk, then the analysis can take a long time. If it's not a big disk, then it won't take that long. Earlier, we had a chance to explore some options here on the left. If we look under Views at File Types, and then by MIME Types, we can now see that it's categorized. And here, we see file types based on the application. Beneath that, we see audio and types of audio that we managed to find on this forensic image. We also see images and text messages. We now have files for web bookmarks and web cookies. Web cookies show us the cookies for all the websites that were visited, including their value and what program used them. Here we see what domain it belongs to. And here we see the user's web history and what websites the user was browsing. A bit further down we have URLs. The system managed to extract all of the URLs. If we double-click it, it uses this regular expression to extract all of these URLs. So, these are all of the URLs found in this forensic image. It also provides a count of how many times the URL was found. We can even sort them. We can see that this URL was found 7,195 times within this forensic image. This gives us a great idea of the browsing history. For websites like this one here that contain the w3.org, don't forget that it's related to standards, and you may find it in most websites you visit, so it may not be directly related to the investigation. Let's look at email addresses next. Here we see that they are also sorted out. We can also see how many times a particular email was used. So, for example, we see 2 here, meaning that it was found in 2 files. Here, we see email messages. As we scroll up, let's quickly check the places we visited earlier. We can now see the total of files for these. Let's now do a keyword search. Here is an example of a search that I did during the analysis of the system. If we go to single literal keyword search and expand it, we will find that the keyword verisign.com was found in 9 files. Let's try an example search and type in garden. It will now search the forensic image for files where the word garden is found. If we click on this file, it even highlights the word garden for us. The search found the word garden in 46 files. Again, if we click a file, it will highlight the word for us and show us where the word was found. Let's now look at installed programs. The count was at 16 before we paused the video, but after Autopsy finished analysis, it was able to find new results, and the total is now 31. Also, if you're interested in a particular file and you want to extract it, you can simply select it and right-click it. This allows us to save the file, where we can access it later for another analysis or use it with a different tool. Like with ntuser.dat, this can be used to analyze the user profile settings that are found here. Extraction is not limited to files. We can also extract a directory. As you can see, there are a lot of things we can do using Autopsy, like search for files based on categories, types, extensions, or whether they were deleted or not. We can also search based on size. Here we already have some extracted content based on what specific type they are, like an attached device or XF metadata on an image. We can even look at recent documents. Before we conclude the video, I want to add 2 final points. If you ever want to stop analysis and work on it later, click on the Close Case button here so it properly shuts down, so all the analysis that's been done will be stored in a container created by Autopsy. You can then come back later and begin working where you left off. So, make sure you close the case, not exit it. Next, should you want to add another data source, like another disk image to the same case, you can go to Case, then Add Other Sources, select Disk Image or VM file, and proceed to add it. And this concludes our video lesson on working with Autopsy. Thank you for joining us.